Now let's move to the writing part question number 18. The lesson objective is as such: list the characteristics of the interaction pair and identify the action and reaction pairs of different situations. So we have moved on to Newton's third law. The first two we were discussing about Newton's first and second law, and we applied forces, how to identify the net force and so on. Now this is a totally different situation when applying Newton's third law. Now the statement is there. What does it state? That all forces come in pairs. Pairs means what? You will have two, right? It will be a set of two, and that the forces are equal in strength, opposite in direction, act on different objects. Now the wordings might be a little confusing to you, but if you understand it, then you will not forget, you will always remember. Now the easiest example that you could relate to is if there is a wall or any board or something, you're just punching on the wall, your direction of force is towards the wall, correct? And you apply some force. Let's assume you are applying 50 Newton force and you punch on the wall, and you also get hurt. Although the force is applied on the wall, your hand also is hurt. So why is that? Because it is applying a force of similar or the same magnitude is acted upon on your hand. Now if you increase the force, you will feel that you are hurt more. If you exert double the force, so you get hurt doubled, right? Now if you look at the direction, see, that's opposite, right? It's your hand is acting on the wall in the left direction, and in the opposite direction is where the wall is acting on your hand. And if you look at the magnitude, the number or the value or the size of the force, it's the same. 50 Newton, here also it's 50 Newton. So if you look at the first two phrases, two forces are equal in strength. When you say equal in strength, it's equal in the numbers, and opposite in direction. I hope that you got that now. And this is a very key factor in identifying whether it is Newton's first or second or third, because sometimes they could give you a situation and ask you, is this Newton's first law? Is this an example of second or third? Okay, to differentiate from first, two and three, this is your key. So you should have two different objects where the forces are acting. See, in this case, which are the two different objects? One is the hand and the other one is wall. So the one force is acting on the hand, the other force is acting on the wall, so it is Newton's third law. It's a third law pair. Okay, now let's come to this. And also how do we represent it? You will find this formula or an equation where force A on B equals negative force B on A. The negative sign indicates that the direction is opposite. Alright, the negative sign indicates that the direction of these two forces are in the opposite direction. Although the 50 Newton is equal to 50 Newton, but this is in the positive direction, this is in the negative direction. So you have that sign convention is different. Alright, let's take this example question here. Now let's analyze what are the two, when you say that Newton's third law pair, they could ask you to write, or choices might be given to you to choose the correct one. So if you take the football, the ball as separate, and we always draw the free body diagram for the ball itself. So what are the forces acting on it? The ball is in contact with the table, so there should be a contact force or the normal force acting upwards, and as always there is a downward force, that is force of gravity. So you have the normal force acting up and force of gravity acting down, and look, I have kept the length equal because it's at rest, it's in equilibrium state. So these two are representing what? Newton's first law. Why? Because it is acting on one object. Try to differentiate that. So these two forces, normal force and force of gravity, are not Newton's third law pair, but it is This one is not Newton's third law pair, but it is Newton's first law. Okay, forces are equal, the net force is 0, and so on and so forth, right? Okay. Now, so this is the force for the ball. Now, if you take the table will also have two forces, which is its table's weight Fg. Let's put another subscript T. That's a force of gravity on for the table, and there will be a normal force acting on the table as well. Right? Now, is this Newton's third law? Again, no, because this is your table. This is for table. Okay, all right. So here there are two objects, so we can identify the Newton's third law pair, which is, now I'll first write the statement and then I will tell you how to make it easily without even thinking, without even going through all these steps and processes, which is, now the force of G, gravity, on the ball by earth. Right, this is one force acting on the ball. Now the ball will also, there should be a counter force, because Newton's third law states that always the forces exist in pair. It cannot come in one. Okay, there has to be a counter force that is acting in the opposite direction. So if you take this as the positive force, or one force acting, okay, where is it acting? The force of gravity on the ball. It's acting on the ball by earth. Now the counter force will be force of the same force. You start with the same statement, force of gravity. You have to write it in full. I'm just, force of gravity on the earth by the ball. Okay. Now here, see, if you look at it, this is what I was telling you. I'll give you a hint. It's everything is the same except for these two objects. See, force of gravity here, same. Force of gravity here also is the same. On these two are switched. See, the ball and the earth are switched in these two cases. That's, again, this is without understanding. If you want to memorize it and learn it by heart, that's one tip and trick. But otherwise, what I explained earlier is the actual explanation for Newton's third law. So this is one pair of Newton's third law in this particular situation, when the ball, or even for the table you can write, is a force of gravity acting on the table by the earth, and similarly you swap it, force of gravity acting on the earth by the table. Just swap the objects. And also you can write the normal force by the table on the ball and normal force by the ball on the table. That also is Newton's third law pair. Right? So just going over once again. So what is Newton's third law? The characteristics are three characteristics. What are they? Both will be equal in, the two forces will be equal in magnitude or equal in strength, equal in size, but they will be opposite in direction, and they will act on different objects. They will act on different objects. Then the formula is this, and how to identify the two force pair is, they will have the same type of force. If it's one is force of gravity, the other one also will be force of gravity. If one is a tension force, the other one also will be tension force. But what's the difference? It will be acting on two different objects and not on the same object, like the free body diagram. Then it moves to Newton's first law or second law. Okay. So one object, if the forces are acting, it is Newton's either first or second law. If it's acting on two objects, and if it is of the same type of force, and if you have them acting in the opposite direction, then it is third law pair.